Before we start this video, a large thank you to KJTelFlix. I'm totally butchering that. Thank you for the support, my man. Jonas, J, CC, Nicholas, Solaire, Jericho, Chen, Landtresser, welcome back Landtresser, and Yuval. I hope I'm pronouncing that right. That is a cool name. Thank you for the support, guys, and I hope you enjoy the video. Man, I hope you guys are a fan of breaking stuff, because we're going to break some stuff. Okay, so open up the combat state humanoid manager, or state script rather. And now we're going to go through all this. This is just the code from the old one, and we're going to see what we need and what we don't. So we don't need attack state.hasPerform attack. We're going to reset that after we leave the attack state. I'll explain more on that in the next video. Let's not worry about that for now. We're going to say if the character is not grounded or the character is performing an action, interacting on this project, then we want to halt all movement. So let's just do that. And I'm going to comment on all this stuff too and write notes above it all so it is very clear when we start layering it on and we come back to this from a long time from now if we need to look at it. So I'm going to copy this logic in here from is interacting and delete it so we can put both of these in one if statement here. And I'm going to make a comment up here, just as what I said. If the AI is not grounded or is falling or is performing some sort of action, then let's halt or stop the movement. All right, so next, let's go down to the next if statement. This looks fine. I'm just going to make a comment. If the AI's target gets too far away from the AI, then we return the AI to the pursue target state. Pretty self-explanatory. This random destination set, see, we haven't been here in a long time, but I do remember what this is. Going to check it just to make sure. I believe this is deciding if our AI has been giving a random strafing pattern. I'm 99% sure. Yes, it is. So make a comment above here. Randomizes the walking pattern, or you can say strafing pattern of the AI. We're going to revisit this a little bit in the future and make it so we can run, not only walk as well. And you can set between the slow or fast settings, but we'll leave that as it is for now because we have a lot of work to do. So let's go now to the project, and I'm going to open up the enemy manager. I'm going to do it from the project, so it's actually a tab in the Visual Studios and not just a tab that's temporary. And now right here below AI settings, I'm going to add another header called Advanced AI Settings. And I'm going to make a note here that these settings will only affect the AI who use the humanoid or advanced state scripts. So if you'd rather put these settings on the advanced state scripts themselves, that's okay as well. I just personally like having all my settings on the main enemy manager. I just find it's easy to quickly adjust things on the fly when testing, but do as you so please. So what are we going to need? Well, we're going to need quite a few things this video. Starting off, I'm going to say public bool allow AI to perform block. And then from there, we're also going to make another one called allow AI to perform dodge. And then lastly, we're going to add allow AI to perform parry. So we need a way to determine the percentage of likelihood that the AI will perform this action. So underneath each of these, add an integer. You can use a float if you want, but I'm going to call this block likelihood. And I'm going to initialize it at 50, just so it's always something. And I'm going to do the same thing with dodge and parry. And the way I'm going to think about it is this. I'm going to use an integer always between 0 and 100. 0 being 0% of the time, 100 being 100% of the time. And then we're going to use that to determine the percentage of the time in the combat stance state this AI will attempt to perform a block, a dodge when attacked, or a parry. So just going to make a note here so in the future it's very clear. Number from 0 to 100, 100% will generate a block every time. 0% will generate a block 0% of the time. I should add a percentage symbol to all these so it's more clear. There we go. So yeah, that's very straightforward. This is how we're going to basically determine the likelihood between each enemy, so you can adjust it on the fly. If you want one enemy to dodge more, you can just crank this up as much as you so please. So back here on the combat stance humanoid script, let's make some more statements here within the main sword and shield tick method. I'm going to say if enemy.allow to perform block, well, we want to roll for a block chance. Let's see if we roll and land on a block. And if we do, then we can allow our enemy to block. So let's make the roll chance for this now. All right, so I'm going to say AI rolls down here just so we know what this is. And I'm going to start off by saying private void roll for block chance. And then we're going to need to pass the enemy manager because we need the likelihood that we're weighing it against. And very, very, very simply put, we're just going to make a temporary variable of type integer. Going to call it block chance, and I'm going to initialize that at random dot range between 0 and 100. That's meant to be equal, not minus. So what we want to do then is compare the result of this integer against the block chance we have in our enemy's manager. So we're going to say if block chance is less than or equal to the enemy dot block likelihood, then we will perform a block. If not, we will not perform a block. So we need to make a bool now in this stance script to determine if we're going to perform a block. So let's go up there and do that. Let's make 3 actually. We're going to call these state flags from now on, because these are going to be flags that are reset at the end of every state. So when you leave the state, they all go back to false. And these will determine actions within the state. So we'll start off by saying bool will perform block, initialize that at false, will perform dodge, initialize that at false, and will perform parry, initialize that at false. So as you just seen, we rolled for a block chance. If we roll successfully, we're going to change that bool from false to true. So we're going to say will perform block equals true. Otherwise, will perform block equals false. All right, so now we're going to call this function here. But before we do that, actually, let's just go ahead and make a private reset state flags. That's supposed to be a void, private void reset state flags. And we're going to call this function on every state when we leave the state. So every state will have their own if we're using flags. And what you want to do is take every state flag and set them back to false. So when we come back into the state, we have to re-roll for all these chances. Otherwise, what's going to happen is when you come back in, the AI is going to perform any successful function that it rolled correctly on the last state. We don't want that. We want to re-roll every time we come in. Otherwise, there's no point really in making it a percentage likelihood. It will just happen every single time after one success. So now that that's done, let's go up here and right where we had the pseudocode for roll for a block chance, let's put in roll for a block chance. And now we'll roll and calculate it. And then right below that, we want to make another if statement, and we're going to say if will perform block. Let's make some pseudocode for will perform a block. Now, this relies on item actions, which we don't have set up just yet. So we're going to come back to this, item-based actions. So if you're holding a shield, for example, we're going to use the shield to perform a block. But before we go back to that, let's copy and paste this allow AI to perform block 3 times. And let's change this to if enemy allowed to perform dodge, and if enemy allowed to perform parry, and just change the word block to dodge and parry. So basically we're doing the same thing. We're going to roll for a dodge chance and roll for a parry chance. And we don't have that function made yet. So we're going to make the 2 of those as well. And let's go down here. If allowed to perform parry, there we go. All right. So then copy and paste the roll for block chance twice. And again, change block the first time to dodge across the whole function, and then change it to parry. And the logic is working exactly the same. We're going to start off with a random integer, and we're going to compare it against the likelihood that the AI has set up in the enemy manager. And if it passes, then the AI will then perform a dodge while the enemy is attacking, or a parry. Okay, that looks good. Just going to read over this. All right, so I'm just going to explain some stuff now while I'm kind of changing this over. So basically right now we have item-based actions for a player, meaning if you hit the right bumper, it checks your right-handed weapon and looks for the action that would basically relate to the right bumper, which is usually a light attack. So this works for the player, but we're going to make it so the AI can use this as well. And this will be great because then depending on what weapons you give your AI, their attacks will change. So for any kind of invaders or humanoid AI you want to customize, you can change their attacks by just swapping weapons out on the fly. Basically, we're going to make them use the weapon set of the weapons they are holding. And in the future, we'll add spells and archery as well, but we're going to start with melee. So to do this, I'm just going to make another check here now. We're going to say if will perform dodge, then we're going to put some pseudocode here. And also if will perform parry, let's just put some pseudocode there. So in order to make this work, we have to basically change our item-based actions from requiring a player manager to a character manager. And I remember a long time ago, we did a refactor on that where we made the player and the character AI share a lot of the same code. Well, this is where it's going to come in handy because now we can basically seamlessly do this by just changing a few variable names. Might need to change a couple of things here and there, but for the most part, everything will work just by changing variable names, which is excellent. All right, so let's save this now. And where am I at in my notes? Right, so the enemy attack actions, if we go here, you can see we just basically play an animation and we check for our angles and our distance for the attack. And that's fine for simple AI, especially things like animals and dogs and whatnot. But What we want to do is now make a script that basically has a lot more functionality and complexity. And we're going to use that for, again, the humanoid advanced-based AI. So I don't know why I just made a folder. Don't mind me. I'm going to go to the advanced AI scripts area and make a new script. This is in a state technically, but I'm just going to keep it here so it's a little bit neater for now. I'm going to call it item-based attack action. And I'm going to open that up right now. And then we're going to erase the start and update, put in my namespace. Mine is SG as is per tradition. You put in whatever yours is. And let's get started. So the first thing we're going to want to know, and before I do that, I'm actually going to change enemy attack action to item-based attack action. This is on the combat stance humanoid script. So let's just save that and don't mind the errors. They will go away eventually. So the first thing we're going to want to know is the attack type. So let's make a header. I'm going to call it attack type. And we know if this is a light attack or a heavy attack. And furthermore, if it's a melee, ranged, or a magic attack. So public attack type is equal to, let's initialize it at light. So whenever you make one of these, the default setting most of the time will be light. And then we need to make a new enum. So let's go over to our enum scripts because we need to know if the AI is using a ranged weapon, if they're using a melee weapon, or if they're using a caster weapon, because that's going to change our logic. So I'm going to make a public enum called AI attack action type. And then I'm going to make 3 melee attack action. And then I can make magic attack action. And then I'm going to make ranged attack action, which will be for bows and crossbows. And then let's go back into the item-based attack action script. And let's just initialize it at melee. And all this does is if you just make one in the inspector, it's going to start off with these values. You can change them, obviously, but most of the attacks you're going to make are probably going to be melee for the most part, at least in the early stages of testing for sure, because we've been doing most of these things with melee. And I'm just going to say attack action equals AI attack action type dot melee action. Okay, so what else do we need to know? Well, we need to know if this action can combo after it has been completed. Some attacks can't combo, like a jumping attack or a running attack. So let's make a header called action combo settings. And I'm going to make a public bool called action can combo, initializing it at false, just in case this is some kind of special attack, although likely most actions can't combo, so you can initialize that at true if you'd like. And then I'm going to make a header again just below that. I'm going to call this right hand or left hand action. And as the header suggests, let's make a bool, or you can do an enum for left or right hand if you want. I'm just going to say bool is right-handed because if it's not right-handed, it's left-handed. But if you have like 6 hands, go ahead and just do an enum for each hand type. And then down here, let's open up the enemy attack action. This is the regular script, and let's copy all this logic because all the ints and floats, I mean, not the 2 top things here. And then we can paste that right down below here because this stays the same. We still need to check for a minimum and maximum angle and a minimum and maximum distance. So I'm going to make a header, and I'm going to call this action settings. All right, now this is where it's going to start to get thicker and more dense. But honestly, still pretty straightforward. I'll make this very clear and concise as I possibly can. So let's make a public void, and let's call this perform attack action. And then in here, I'm going to pass the enemy manager, or I'm going to require the enemy manager, and I'm going to call it enemy. And I'm going to say, if we're using a right-handed action, well, let's do some pseudocode for, let's do a right-handed attack action. If we're using a left, let's do a left-handed attack action. So I'm going to do this in the order of operations. First, we need to perform the action. And the first step is to decide, okay, which hand are we using? So if it's a right-handed action, I'm going to say enemy.is using right hand equals, actually, I'm not going to say that because I have a function set up for this, I believe. Let's make sure, let's check. Enemy.yes, update which hand the character is using. I'm going to say true because this is the right hand. And down here, I will say false because this is the left. So from here, we've decided which hand we're using. Great. Now we know which weapon we're going to be attacking with. So let's make some pseudocode here. And let's say enemy dot, whoops, that's not pseudocode. I'm actually trying to write something. Let's erase that and let's just make a line here and say perform. I'm just going to actually type out the function name because we're going to make it in a second anyway. So perform right hand item action based on attack type. And that title, or that name, let's pass the enemy manager, is exactly what it suggests. We're going to perform a right-handed attack action based on which attack type. And then down here is perform a left-handed attack action based on the attack type. So what's the attack type? Well, is it melee, is it magic, or is it range? So now we have to decide that. So down here I'm going to say decide which hand performs the action. And then I'm going to say private void perform right hand item action based on attack type. And then I'm going to pass again the enemy manager. Going to require enemy manager, sorry. And call that enemy. And then do the exact same thing, but with left hand. So you can see how every step it gets a bit more advanced. First, we're deciding which hand. Okay, now we're deciding which attack type. So obviously, if it's melee, it's going to be different than if it's range or magic. So in here, I'm going to say if attack action type is equal to attack type dot melee action, then some pseudocode, let's perform a melee attack action. I'm going to copy that again and do the same thing for magic and for range. And then the pseudocode will read, okay, perform a ranged attack action. And if not, the pseudocode will read perform a magic attack action. And the same is true down here for left-handed action, except instead of the right weapon in our inventory, we're going to be checking it against the left weapon in our inventory. So I'm breaking it down to individual functions, so it's very easy to understand, and it's not so crowded. You can actually read this from the top to the bottom, and as you read the function names, it makes sense because it just layers off and layers off and layers off. So let's actually do the first one here now. Let's do the right-handed melee action. So I'm going to say private void perform right-handed melee attack action. So we've decided our hand, and we've decided the action type, which is melee. So this function is perform right-hand melee action. And I'm going to make a comment here. I'm going to call that right-handed actions, and then down below you can make one for left-hand actions. So first let's check for two-handing. So if the enemy is two-handing a weapon, well, we know we want to use a two-handed action. Else, we want to use a one-handed action because you can two-hand the right weapon. So then we're going to say if attack type equals light. Now this is attack type, not our, that should be a lowercase I, not our action attack type. This is if it's a light attack or a heavy attack. So if our attack type equals attack type.light, then we know we're performing a light attack. Now, which button will be a light attack? Well, that's usually the right bumper. So what we're going to do, since this is the right-handed action, and this is a two-handed action, we're going to say enemy dot character inventory manager, because we don't have an enemy inventory manager, dot right weapon dot perform, and we're going to perform the two-handed RB action, which is typically the light-handed, the light two-handed attack action. And we're going to say dot perform action and pass the enemy. Now you see we have an error. This is because we're asking for a player manager, but we're passing an enemy manager. But we're going to make it in this video so it requires a character manager, which is the base class of both, so you can use either, which means the player or the AI can use this, which is great because then it becomes more modular. Now we're going to do the same thing for heavy, except we're going to place tap RB with tap RT, because we know usually our RT action represents our heavy attack. And then do the same down here, but for one-handing it. So change TH to OH, and there you go. We have the functionality set up. Now comes the more time-consuming part. What we have to do now is we have to go through these actions before, and I'm going to open one up and show you. Let's start off. Let's just open them all up first because this has to be done. In the future, we're going to give the AI the ability to perform every bit of logic the player can, from parrying to shooting a bow to casting a spell to light attacks, heavy attacks, etc., etc. So open up all of these scripts, and what we're going to do is start off with the base class script, which is just called item action. And then we are going, so we can find that by right-clicking here and go to definition. And we're going to change player manager to character manager and change the player variable to a character variable. And this allows both player and enemy manager to use this functionality. Now, you might ask yourself, okay, but what if right here, for example, we require the UI? Character managers don't have a UI. That's fine. I'll show you what we can do. Let's start off by actually making this character manager, and then we're going to make a variable of type player manager. And let's change this character first. So let's make a variable of type player manager, and then we're going to call that player, and we're going to say player equals character as player manager. And then we're just going to cast it. So if the character is a player manager, we get that, and then we check and we say if our player is not null. So if we actually have a player manager, then we will update the player's UI right here, and we'll change character to player. We only have to do this a couple of times because most of these scripts don't use the UI. Most are just accessing the inventory and the animator, so that's fine. So let's put player right there. And that is how we do it. So that works as intended now. Now we have to do this to almost every other script. So I am just going to go over here now and go to the heavy attack. We'll do the heavy attack and the light attack in this video so I can show you a demonstration. Change the character manager to character, rename player to character. Don't change it or else you have to rename every one of these variables by hand. That just adds more time. So what's going on here? Well, we know right now we have stamina across both, so change character or player stats to character stats. Basically, everywhere you see player, change it to character because we've already done the legwork here. We've already made base classes for all these scripts. And here we have a relic of our old code. We don't need to check the input manager, just check the character can combo. So erase that. And basically, we used to check the input manager for a combo status, but now it's actually saved to the character manager script. So you can erase that. And again, change wherever you see player to character. And we have a similar relic up here. So we used to check the two-handed flag on the input manager, but we can just check it also on the character for is two-handing weapon. So I'll show you momentarily. Again, keep changing wherever you see player to character. Now, we do have to change one thing. On the character combat manager, we don't have a last attack variable, and we don't have the attack string names. This is easily fixed. And right here, for character.inputmanager.twohand flag, change it to character.is2handing weapon. You can check the two-handed flag on the input manager, but the is two-handing weapon variable is saved on the character manager, which is way more universal. So what you're seeing here is this old code is less modular, and it was when we first started prototyping the systems. But now we have a system that works for everything all around at once. So next we have to go to the character combat manager and the player combat manager. What you want to do is copy the last attack variable and all of these attack animation variables. Go to the character combat manager here and just paste that in there like so, and then save it. So when we go back here now to the heavy attack option, then I actually didn't copy the attack animation names, and I just said that out loud. Okay, so copy all of these as well, just right from the weapon art and everything, and delete them all from the player combat manager and put them in the character combat manager. This makes them accessible to both the AI and the player, so both can use them. And again, continue with your parade of turning the word player into character wherever you see it, and that is honestly all you have to do. The only exception is wherever you see a check for two-handed that checks the input manager, instead of looking for two-handed flag on the input manager, just look for two-handed on the character manager because both the player and the AI use that. So I'm going to talk over this while I do it because this is more mindless copy and pasting. I'll even show you just, again, for clarity. See, input handler, two-hand flag? No, just erase the input handler altogether and check character.is two-handing weapon because, again, that is used by both the player and the AI, so we can use that as a shared variable. They both work in the exact same way. So, as I was saying, I'm going to talk over this now. So the plan is to basically change every single one of these item actions to a more modular state as we are doing now, and this will allow our AI to use them and our player to use them. And if we get to an instance where there is some sort of logic, for example, that is only applicable to the AI, which will happen in archery, or it is only applicable to the player, which again will happen in archery, we're going to cast a variable of their specific type. So for example, if you have a player manager or a player that requires you to edit the UI manager, at the beginning of the function, we will say player manager player is equal to character as a player manager. And all this does is if the base class or if the class that's running this script is a player manager, then we can use it as a player manager instead of using it as a character manager, which will give us access to the things that the player only has. Likewise, we can do the same thing for the enemy manager. So if we have to access something that only the enemy manager has, we would cast it as an enemy manager. Casting just basically allows you to run the base variable as something else. So for example, we're only using the character manager variable in here, but as you know, the character manager variable is the base class for both our player and our enemy managers. So instead of using a character manager, it would allow us to use either of those in its place. That is a simple explanation, as simple as I can word it anyway. If you're confused, just check out how casting works. All right, so that looks good here on the heavy attack action. So let's jump over to the light attack action because that's one we're actually looking to test right now. So, or remove the error from, I should say. So I'm going to change player again to character, and then I'm going to rename player to character. Do that so it will save you some copy and pasting. And right where you see the player, change it to character. And as you can see here, we have an old relic checking our input manager for a combo flag. We don't need to do that. Or we're setting it there. We don't need to do that. Just actually check the character can do combo because we're setting that in the animator. Okay, so again, change the word player to character and do this over here as well. In the next video, when I finish doing these, I'm going to have a timestamp so you can skip it, because I know a lot of you can do this on your own, but if a couple of you are confused as to when to use the casts, I'll record myself doing it, but I'll put a segment in where you can skip ahead if you want to not watch all this. But I am going to conclude the video doing this one so I can go back into the new script we made and show you that it works as intended. We can't run the game though, because we won't be able to until we rewrite or refactor all the item-based actions, because it will give us an error in the inspector. So that looks good. Again, the logic is the same throughout. Wherever you find input handler two-hand flag, replace it with character.is two-handing weapon, and replace the word player with character. So that should be just fine. Yep, that's good. And these are the last few here. Now we have to rewrite before I go back and see if the code is not errored anymore on the item-based action script. There we go, change that. And this will basically allow us, again, to anything that we make in the future for the player in terms of item-based actions, we'll be able to use the logic on our AI as well. So that makes your humanoid AI a lot more modular, and it also separates them from the regular AI, because if you have an AI like a dog, for example, or an undead, you want them to be a bit more basic in their attack styles. They probably have preset attack animations you're going to allow them to use, and that might not be the case for all of them, but definitely for a lot of them. The same is true with monster AI. A lot of them are going to be using the same attack patterns, but this allows you to tweak and kind of customize and really scale the difficulty of your humanoid AI characters. I'm going to use this in my project for the more difficult AI, the more rare encounters. This won't be the generic encounters that you'll come across, but I mean, you use it for whatever you want to use it for. You can make every AI in your game like this if you wanted to. All right, these are the last few here. Just going to talk over this as I copy and paste them. Okay, there we go. So in the next video, I'm actually going to, regardless of how long it is, if you guys want to, actually, I'll let you guys decide. I can steamroll the rest of this and we can actually get it to a working and near complete state in the next video, or we can break it off into two, because I predict if I do it in one, it might be upwards of an hour, 45 minutes. It might not be. I might be able to get through it really quickly, but yeah, I'm anticipating a couple things I'm going to have to rewrite or change. So if you guys want to see it in one video, I can do that. If you'd rather see it in two 30-minute videos or two 25-minute videos, I can do that as well. Just let me know down below. I'd like to hear your input on it. So now you can see no error here. So we actually can use our AI to perform an action based on the item they are holding, and that will work just fine. So now up here where we say perform right-handed melee action, let's just actually call it function. Now this actually would work if we had all of the other item-based action scripts refactored, because right now you will see if I minimize this, the inspector is going to throw us errors. So we will finish refactoring those scripts in the next episode, and then we will actually get around to writing the dodging and parrying and blocking logic as well. It will be super simple. I'll show you guys how I do it, and at least I think it's very straightforward and straight to the point. So as usual, guys, if you are a champion and you're this far in the series and you've made it this far, don't forget to drop a like and leave a comment. It does genuinely help out the series so much. We're really getting to the fun stuff now, so I'm looking forward to posting the next episode. I will see you guys then.